next speaker, who will be the last one in this session of the track, is Geoff Hollingworth. Geoff is currently Chief Marketing Officer at Mobile Edge X and spent significant time with Ericsson previously. Geoff has also graciously agreed to join us from the infamous CQR cast of characters. So thank you very much, Geoff.
Thank you very much. Good afternoon. I'm hoping this is going to be the most esoteric and psychedelic presentation of this whole 3 days. So my name's Geoff Hollingworth. I work for a company called Mobile Edge X. The reason that Mobile Edge X is different is because we don't do infrastructure. We don't do technology. We were created by the operators that are buying all of this technology. And our mission and the reason that we were created was to find who is actually going to use it so we can solve real-world problems and then bring actual business and demand back into the technology. So I'm not going to speak overly about technology. We can speak about technology if you're desperate to go down and you're missing it. But otherwise, this conversation is going to stay at the level of who is edge computing actually for. And when I say edge computing, I include in that distributed cloud, I include in that 5G, I include everything that comes next, because that's what everybody is doing. Everyone has a different symbol or a different label, but what they're really talking about is building what comes next to seize that opportunity. So we're going to run through a modeling exercise we're trying to construct on how to make a simple understanding of the landscape people are sat in, and then understand what potentially can change and what the values are. Because one thing I think Dean is bringing up underneath some of his questions is that we're not living in a greenfield world. We're living in an existing world, but people will be doing different things 5 years from now. Now, about 9 months ago, we actually released, I'm just looking, how do I put this in projector mode? I am completely Mac damaged. Which is a bit like being Windows damaged, but more expensive. Slideshare, there we go. There we go. Wow, that was awful.
The open source project.
There we go. Hey. That was, if none of us knew what latency was, that was an example of latency. And notice it had nothing to do with networking. So about 9 months ago, we released all of the research that we had inherited from Deutsche Telekom around use cases, why they needed edge, the different enablers that were required. And that's something that we called the Edge Navigator. And if you go to mobileedgex.com and click on use cases, you can see all of that research. What we are now doing is looking at the way we approach that problem and adjusting based on what we think we know now, based on our interactions. And that's what I'm going to walk you through today. And I want to start with a really taking a step back perspective. It's really hard to see the future, but we all believe we're talking about it when we're talking about it. But we tend not to be, because we're talking about an iteration of today projected tomorrow. Very hard to flip that perspective. And I think that's exactly where we are in the moment. In 2007, the biggest selling device was the Nokia 1200. It was selling 150 million devices a year. If you'd asked anybody then who was going to own the next 10, 15, 20, 100 years of mobile business, people would have said Nokia. And obviously, the next year, Apple came out, Android came out, and they decided it wasn't about communication anymore, it was about computation. And the device was a platform where speaking was just something else that you did on it. That's where we've been for the last 10 to 12 to 13 years. When I speak to anybody today, no one tells me that Apple, Android, Amazon, they're going to live forever again, because we don't need anything else. But if we start looking through the lens of the changing experiences we start to see, then the key word that starts to come out is augmentation. Now, if you get incredibly esoteric at this point, humans are the only animals that have augmented the real world at all. And we did that through the simple adoption of language and symbols to allow ourselves to actually communicate with each other and develop constructs. And we built our own augmentation of nature. We are the only animals that understand something that's not physically there. That's why the dog that you have is a lot happier than you are. Because it always lives in the present, and when it gets food, it's happy. When it doesn't get food, it doesn't care. Whereas you're worried about whether you're going to get food, or you're worried you had too much food. But very few of us are actually living in the present. It wasn't until about the 1850s or 1700s where we started augmenting our senses. And the biggest augmentation we did at mass scale was communication, because it extended the natural augmentation of me speaking to you to me speaking to anybody anywhere, to a fixed location for most of them. Then we augmented all of our calculations around data, our applications, our processors, and that's the app revolution that's been going on. Now we're moving into a world where we're augmenting our physical reality around us from every single sense. And let's just break that down a little bit. So if you go to the App Store today on iOS, there's already over 2,000 apps that are doing something with augmented visual reality. And again, what we have to understand is, in actual fact, what we believe is real as human beings is just an interpretation of what we're receiving through all of our natural senses. All this is doing is building another level of reality that we believe is true. But it is extending what we understand in the context we are. Oral augmentation, the ability suddenly to understand in real time any language and converse in any language. One of the largest applications that's making the biggest difference to people today are ones where they're visually impaired, and there's now applications that can interpret what's being said into an audio, an oral translation. There's spatial, allowing a navigational awareness around the space even though you don't understand it, you've never been there. That's the driver of Uber, the driver of Lyft. There's a great story of someone I think it was a Ukrainian turning up in San Francisco who just wanted to discover the city. So they became an Uber driver in the city and was guiding everybody around. And the people that he's guiding around have just been there a day less than he has. But he is completely augmented from the point of view that he understands and he can do that full job. In London, you had to pass something called the test, meaning you had to know each street and each route, otherwise you weren't allowed to be a taxi driver. And you can still do that. It's a manual Uber. It was like before Uber. Contextual augmentation is where you can space shift. I can't be at the NBA game, but I can absolutely be at the NBA game. I can't be watching the game with my friends, but I can absolutely be watching the game with my friends. And then time shifting. I can actually move backwards and forwards through a construction site, through a historical experience. All of those things become available because, again, both of those things are just concepts. Physical resistance, I don't know if any of you have ever tried this, but there's now adaptions for hands, so you can touch virtual objects and they give resistance, so you catch them. It's pretty freaky, actually. And then the last one is what I call mechanical augmentation, meaning that there are certain machines that are becoming intelligent and human-like. So anything with the concept of autonomy or autonomous starts to take on the behaviors of something intelligent. Now, in each but one of those boxes, there are business models and values that allow people to do things they couldn't do today, that make today look very, very ineffective. And that's what I think we need to get to. Now, the next bit that we skip over, and this is tying back to some of the technical presentations, there is a reason why humans understand reality better than animals. And it's because our brains are interconnected to a much greater level than all other animals, which means that we can actually do pattern matching and we can actually make decisions and correlations that other animals cannot do. From a topology of the network, this is what we start to need to create. And this is what we don't have today. At the moment, and this is what I was hearing again from the Dean and Kelly discussion, there are very thick synapses that run through the networks today that take actually the event triggers a long distance away from the locality of what happened. And there's a whole business inside our industry called interconnection peering points that all sit at the edge of the GI interface, that then everybody resides and everybody is highly interconnected. I think as we start to move forward with edge computing and this moves further out, those interconnection points need to move further out to that points of presence, so there is a locality of understanding where that is. And this is very similar a deployment strategy I think we will see as to the starts of mobile. So anyone that's old enough in the mobile industry to remember when mobile phones started, you would buy a mobile phone because it just worked in your city, because it was valuable enough to you. And the moment you went out of the city, it just didn't have any ability to work. But in the city, it changed your life. And slowly but surely, it rolled out to that point. So the second half of this is just walking through an initiative we call Seamster, where we're trying to build an abstract model of how we understand what kinds of use cases and what kinds of edge computing can best serve those use cases. So I'm going to walk you through here the simple modeling that we have, because we are then setting up a work in progress to engage with various different companies to try and model everything consistently from a use case point of view. So the first thing that we should understand is perspective is really important. Everybody in this space is coming from their own perspective. And everybody is correct looking through the lens that they are looking through. So you have to have an open mind to understand the perspective people are speaking from and the truth that it's coming from. But there is a difference between true and truth. And one of the most surprising places that we spend a lot of time speaking about is the fact that edge computing is not a new phenomenon at all. All of us, like Kelly's using his phone today, he's using a device edge, he's using a cloud edge. The only thing is that it's passing through potentially an on-premise edge and definitely a telecom edge. But they're just providing, especially the telecom edge, connectivity. Now, each one of these edges has benefits and challenges, and each one should be used the right way. So, for example, the device edge is the most present edge for any application. Why isn't everything on a device edge? Because it becomes incredibly expensive, it becomes incredibly isolated, becomes incredibly heavy. Most of these experiences are mobile. The battery is the biggest problem. It doesn't follow, it's never followed a Moore's law. So you can start to look at offloading from those devices. Now, when we speak to, let's take an example, an Oculus Quest. Who here has used an Oculus Quest, by the way? And do you like it? But when you put it, was it easy to set up and use? Yeah. You've just described Oculus Quest's biggest problem. So Oculus Quest is this all-in-one VR headset. And it's really good because they focused on the usability. I think you get it out of the box, you scan your room, you can play in it, it recognizes your room, it's all in one, you're not hooking it up to some PC. It's great. The problem is, it's still very expensive, and they're subsidizing it, by the way. I don't know if that's public knowledge, but the land grabbing on it is heavy, and thus it's not very portable. So if you can take away expense, weight, and improve battery life, they'll absolutely talk about putting in the additional cost of a modem or something like that if it increases the flexibility on it. Now, the interesting thing about Oculus Quest is the original design before that was something called Oculus Rift. And Oculus Rift actually implemented compute offload. So the games have been designed for compute offload with edge computing in mind. The only thing is, it's got a cable on the back. Number one thing people hate, cables on the back to fixed objects, so you can't move. That's more like prison than experience. Those games are perfectly architected to move to an offload that has not got a tether. Telecom edge is the most interesting because it's the least used. It's the least used by anybody other than telecom. Let's just get this. Okay, I saw Kelly gets used all the time. It's a bit like you've got the chocolate, but you're not sharing. Yeah? More investments in telecom edge over the last 10 years than all the other edges. $2 trillion. That $2 trillion is going to move into 5G, get repeated. There's no doubt about that. The only question is whether that telecom edge will be used by anybody other than telecom. So when we look at all of our network diagrams, I always look at these trying to see if anyone ever puts a user on there and how they actually connect to it. If I look at a diagram from AWS, Google, Microsoft, I don't see any technology diagrams. I see users, interfaces, and flows. But telecom edge is the reason that people are getting excited about edge computing, because all the other edges are existing and used in some way. And the only question is how telecom edge can actually open up markets and change the status quo of today, either to improve what you're doing today or to do something that's not possible. So, for example, we believe that if we looked at how cloud rolled out, it went from public to hybrid to private. What we think edge is going to do is go from private to hybrid to public. So we believe the first people that actually will benefit from a distributed edge are people in large enterprises with multiple on-premise edge computing constellations, where the value to their business is so high that then they need to manage and orchestrate all of those workloads across all of those locations. The moment that is not automated, the moment that is not managed, the moment that is not declarative, that is really, really hard. So just underneath users, it's actually the life cycle management of applications and operations. And of course, the centralized cloud edge is the biggest place where all developers live. We believe that edge computing applications will all be born in public cloud. And what will happen is they'll leave home as they grow up, and they'll slowly populate. The children, the parts of it that make sense, need to automatically populate edge locations when they're needed, and when they're not needed, they disappear. I was listening to a very interesting presentation yesterday from the callstats.io guy. Callstats does real-time diagnostics of web RTC traffic to do AI, machine learning, quality assurance insights. They run probes on every single client that's passing data back. Their biggest problem is managing that data into clusters dynamically, and then actually being able to gather those insights and put them back into a center of inference. That's just one app. Everybody is trying to understand with a greater granularity what's happening in real time so that it can actually make better decisions. We spoke to another person in retail who was telling us that they have deployed IoT systems out in the field, but they can't turn on all of the features because when they do, it releases this tsunami of data and it floods. They want to do that. So we have this pent-up demand, but we are not meeting it with a functional experience that's easy to use that solves those problems. So inside that landscape, we start to construct sentences and a grammar. And the three items that we see in this universe is that you have an augmented human. And the definition of an augmented human is that it's intelligent. It's more intelligent than it's not. It's not saying that a non-augmented human is stupid, by the way. You have an augmented machine, which means it's intelligent. And then you have an augmented thing where it is aware. So things are objects. Humans and machines are subjects, augmented humans, augmented machines. So when we document use cases, we actually went through a lot of investigation on how to inject a discipline in doing this, given the fact that there are so many different perspectives, so many different ways of viewing this world. And we actually ended up using the same approach as law students use to interpret law. And we based it on legal case briefs. So what we try and do in any scenario is we discuss first the facts. And the facts are always around an industry, a user, a value. And then we have a hypothesis on how we can adjust that for the betterment of the situation. We measure the outcome for this, and then we have a score. And the score defines how important is this use case to the people using it. Is it a 10% improvement? Is it transformative? Is it disruptive? What's the ease of adoption? How easy is it to use? And then, how is the ease of spreading? How easy is it to take it from one implementation, say in one retail shop, and do it in all retail shops? How easy is it to take it from retail to manufacturing to transportation? How portable is it? And then we try and size what's most interesting and why. And then the final part of this analysis is modeling that we use second-order thinking and third-order thinking on. So the first-order thinking of edge computing is that the proximity gives you lower latency and the ability for higher bandwidth. The second-order thinking, because you've got low latency and high bandwidth, is you can start to have compute offload, you can start to do endpoint, high-fidelity endpoint synchronization. And at the moment, that is where we are from an edge computing world. People are taking their backends and putting them on edge servers. So if I am a facial or a feature recognition company from a video analytics company, I take my backend and I put it as close as I can to the cameras and devices that are actually being served by it. It extracts the objects and it sends it out. And then if we work with another one of those companies, we take their unique backend and we put it out. And if we work with 100 of those companies, we have 100 backends all doing pretty much the same thing. What we then start to identify is the third-order effect of edge, that actually feature extraction for video is actually an edge-native service that should be provided for everybody rather than being maintained by 100 companies as if it's differentiated. And that's what we think needs to turn up at the edge of these networks. So some simple examples. It's quite refreshing when you start looking through this lens at how many examples are existing today and the difference they're making. And one question I think we're getting wrong as an industry is that we keep asking what's the most important use case. I think the correct answer is what's the most important use case to each of us. Because the answer to that question depends on who you are and what's important. And the power of any platform like this is to be able to accommodate the importance to everybody. But for example, there's already in utilities augmented field maintenance workers. What's the big difference? First big difference, they actually can solve and diagnose more problems because they actually get expert help when they're not expert. The second advantage is that they have less bad jobs. the quality goes up. It can say, no, you did this right, or no, you shouldn't have left the casing open. The third one is around job allocation and the ability for them to understand what the next job to do would be the best to do based on what they understand, what parts they have with them, where they are located. Example number one. Example number two is, and this is coming from the people that are building the Mars lander, so complicated assembly workers. If you've ever tried to build something complicated, having a 300-page manual by the side of you and picking it up and putting it down and putting that bolt in and going, oh, crap, the Martian lander leg looks a bit off, and like carrying on like that. Two advantages. One is that they're training people before they actually do the work, so they're becoming productive twice as fast. And then it's a 68% improvement on the speed they build things. And again, less mistakes. Now, there's an example app, by the way. The consumer example of this is IKEA furniture building, where there's an app doing for that, where it will build you, it'll show you exactly in parallel on your floor as you're building the furniture. That's obviously going to be a lot bigger than the Mars lander. And then augmented healthcare worker. This is interesting because everyone always goes to this remote surgery kind of angle. There's some very simple applications that are already in service just around diagnostics. People picking up gait, whether people are not moving correctly. A lot of work around training people on recovery after accidents. The home healthcare, the actual discipline for taking drugs. One of the big problems after treatment is the fact that people aren't very good at maintaining their own discipline of follow-through therapy. Now, these were just three examples. Every single aspect of life, you can put augmented in front of it and think if it exists yet. The other one the one that really touched me was the augmented disabled people. 3.4 million people in the US that are visually impaired that this technology can change the life for. Augmented gaming, people call that Pokemon and Facebook Oculus. So what we're in the process of, and we'd love to have more conversations, is going through and finding these examples and writing them down in a very simple, consistent manner, scoring them, and then we'll start to run analysis of, well, if we involve a telecom edge, if we involve an on-prem edge, what does it really mean? Is it interesting? Is it not interesting? And that's the end.
Thank you.
Thank you.
All right. We're a couple minutes into the break time, but while we have Geoff here, is there a question or two?
So I went to Seamster, and then you go into Edge Navigator to actually take a look at these use cases. Is that how that works, Geoff?
You go to mobileedgex.com and
Okay.
you go to the Navigator. If you go to seamster.io today,
Yeah.
you can sign up, and then we'll let you know because we're about to open that up.
Okay.
Yeah,
Good.
yeah. So please put your email in if you want to just get that.
So Geoff, what's the difference between a telco edge and, let's say, someone else's local data center? Let's say, Edge Connects or, I don't know, Equinix put something in the nearest city.
So the way that we tried to name these edges is almost from an ownership of type of company. So the telecom edge is the access network, either mobile or fixed, that can be used to reach one of those local data centers to transit today. And the question, so we would put the Equinix data center inside the governance of the centralized cloud edge. Because you can choose to put something in there. You don't have to ask for permission. There's no gatekeeper there. If you want to put something inside telecom, today you're getting special permission to do it, and tomorrow we're hoping we can open that up. Now, where I found your question interesting, by the way, which I thought was more brutal than the FCC question, I thought, was if you can do local breakout of the tower and get immediately into the local network, that's massively valuable. Because I believe as the interconnect moves out, all those tenants start to live there, and you start to get the interconnection at a very localized level. So my brain analogy, I think, is quite powerful, because I think with growing synapses, the more connections we make, we won't know the topology of this thing at the end, I don't think.
All right. Geoff, thank you so much for wrapping up this session.